Hey, happy Sunday. This is PFG Live, the only podcast authorized from the Flat Cave. Welcome aboard, AG. Where you guys are going too fast. AG Greenwood. I knew you had a... Yeah, we'll find you later. Tucker is in here with 76 degrees Fahrenheit and cloudy in Buffalo, New York. There you are. Greenwood AG reports a beautiful day in southern Idaho. 86. Frankenstein wind southwest 3 miles an hour. Back to White Plains, New York, where DBX reports winds are variable at 5 knots. Visibility 10. A few clouds at 2300. Temperature 2.16. From the Edmonton of Alberta, Dale reports 20 degrees absolutely standard. No precipitation, no nothing. Let's see. Bill Olney is with us from Rome, New York, home of the Air Force Research Labs. Weather 78 somethings, 8 mile an hour winds, totally acceptable. Josh is telling us that our audio is check in the southern Manitoba, where it is winds are 320 at 11, gusting 17, temperature 13, dew point 08. Remarks are plentiful but unimportant. Quentin is with us from Echo Hotel Kilo Delta, where it is currently pretty nice. Paul Morley from Dallas says 90 degrees Frankenstein. Severe storms tonight. You folks in Dallas, take care. High winds, hail, and possible tornadoes around the Dallas area. Use caution. Pixel is with us. He's saying that in San Antonio, it is currently winds are 150 at 5 knots. Visibility 10 miles, broken 3,500, temperature 32, dew point 23, altimeter 292, which is a standard altimeter. Chris O is with us at 72 degrees Frankenstein and cloudy in Los Angeles of the California. Welcome. Arstead, 79 Frankenstein and sunny in Peoria, Illinois. Ted Hyde from Casa Pro Resources, where at Kilo Lima Echo it is 240 at 6 knots, visibility 10 miles, broken at 3,000, temperature 32, dew point 23, altimeter 3001. Harvey Newman, welcome aboard, sir, from Santa Rosa, California, reports 64 degrees Fahrenheit, partly cloudy in the Santa Rosa. Wow. Carl Tauber in the People's Republic of Rhode Island says it's 72 degrees and clearing, hopefully. Hope is all we have. Welcome aboard, everybody. It's going to be an awesome day, and I'm pretty excited to be here, mostly because my kid graduated high school. Woo! So we got that done. It was a busy day, busy weekend, and it's all good news. Silo's Garage is with us. Welcome aboard, sir. 73 degrees and partly cloudy in Indiana. Walking back from the store, but wouldn't want to miss this one. You got time. Just save, a couple of the muffins for us. Bart Harkema is reporting 12 degrees science, rain in north of the Netherlands. Hi, Bart. Welcome aboard. Let's see. We have a couple of things on the preliminary agenda before we get to the main event. If you have questions for our guests at any time, feel free to type them into YouTube chat or Discord chat, or get a friend to do it for you, and we will be happy to answer your questions. Let's see. We have a McMaster car catalog giveaway. If you're not in the U.S., I apologize. This is U.S. only. If you would like to join for a completely random drawing of 4 McMaster car catalogs that were donated to the channel, head over to pfg.gg/links, and there's a great big honking button on the page, and you hit that button, you fill out a Google form, and next week we will do the random drawing for not 1, not 2, not 3, but 4 Quattro fine yellow books. Thank you. Josh put it in the Discord. There it is, pfg.gg/links. Look for the big red button hitting you right in the face, and that will get you in for the drawing. Let's see. There is an event coming up, the Bar Z Summer Bash. They did not ask me to promote this, but they're good folks. And if you want more information, head over to Bar Z Industrial, Shaden HKW just find Stan, his YouTube channel. He has a bunch of invite information for the Barcy Summer Bash. That is in Southern California. So if you want to go, that's where you're going to need to be. And what else? I think that's mostly what we got here. Let's see. I have at least one question came in for our guest, which we will cover. Oh, there it is. Thank you, Dale. Dale has the link. It's barzindustrial.com/summer-bash. And it's just barzindustrial.com, all one word, /summer-bash, all lowercase. Make sure you're sitting up straight when you're typing it. So, okay, we're getting questions coming in. Let's explain what's going on here. If you saw the thumbnail, you know we have a wonderful guest today. His name is Adam Balogh. He's with Laney College. He is a master instructor, Kingdom of the Universe. He's running the place. He's basically the guy who teaches everybody everything they need to know. Did I go? Was that okay? Was that good? Okay. Welcome aboard, Mr. Adam Balogh. Sir, you are on the air. Welcome, sir. And how are you today?
I'm doing all right. Can you hear me?
I can hear you just fine, 100%.
On my side, it says that I have an unstable internet connection, which happened right as soon as we went live and everybody got...
Just don't touch anything. You're fine. What we have found, almost without exception, that every member of this group comes up as unstable. So I don't think you have anything to worry about.
Okay, well, I can't see anything except for your profile picture and my video feed. So you're going to be my eyes and ears for this whole thing.
You look great. You look like you're trying to avoid the California heat, and that's okay. So the just a bit of technical information. We found that the phone app for Discord, while it works, for running around, for being a guest on PFG.Live, we would prefer you to be on a computer. It's just easier to navigate all the buttons and stuff. But don't worry, you're fine. You look great. It's great. It's totally fine. Yeah.
Cool.
And
all right.
And when you sit up straight, it looks like the light behind you is an arrow going right through your head. So that that's awesome. No, it's fine. We like it. It's oh, there we go. Okay.
There we go.
That's actually a little better. So before we started, when we were talking in the green room there, having the finger sandwiches, I told you that you may have broken a record. Now, I don't know this for sure because our historian is not here today to rummage through all the records. But he did send me this information, which is that Adam Balogh was a guest on the PFG Live in September 3rd of 2023. January 15th of 2023, May 8th of 2022, and April 24th of 2022. Dude, you have been here a lot, and I appreciate
is that right?
Yeah, and that's why I'm saying you might hold the record for the number of guest appearances. Although I have a suspicion there's one name I have to check, and he knows who he is. I'm looking at his icon right now. But yeah, thank you for coming back.
Yeah, absolutely, man. Thanks for having me. I always enjoy coming on the show.
So just for our new viewers, because there's a bunch of them, why don't you just explain what it is that you do? And then we'll talk about you incessantly.
I am an instructor in and department chair of the machine technology department at Laney College in Oakland, California. And, we teach a wide range of trade skills to train people to be machinists, metrologists, industrial maintenance technicians. Recently, we've been going harder into multi-axis CNC machining and also high-end CNC machining of various types, diamond turning, and micro milling.
Micro milling. I love that. Now, just before I forget, because I will forget, your your most important social media presence is on Instagram. Am I correct?
That is correct.
And the account is Laney
Laney Machine Tech. Laney Machine Tech.
Laney Machine Tech. Laney. Is it machine spelled out? I don't even remember.
Yep. MACHINETECH.
There we go. Laney Machine Tech. Is there any other social media presence? You do have a YouTube channel.
I do, although I haven't been posting stuff to it for a long time now.
Which brings me to the next item. Mr. Evils writes, "We sure wish Adam would post more to YouTube, especially long-form videos." So,
yeah. There's a large part of me that wants to get out of the Instagram thing. It's just become like a very, very different kind of platform than it was when I started in 2020. And, I think YouTube has been pretty consistent throughout the years and is a great place to put those longer form videos and content. So part of me really wants to just like switch over entirely, but I don't have the bandwidth to do both. That's for sure.
Yeah. So when you first came on PFG.Live, it was on Instagram, and it was from my phone and your phone, and that's how we did it. And so yeah, if you need any help on the YouTube side, I don't think you do, but it works better. We can search your stuff better, which is what really I think was Evil's. It was his Evil's intent. So we covered that.
One of the things I've been working on for some time now, and I'm kind of waiting until we got all of the equipment that we needed ready to go and we got fully trained up on it, had a really good process figured out, is to do a multi-part series about like the basics of diamond turning that would go through and like it basically follows the curriculum in the course. It goes through, what is it, talk about the machine design, then go into, why diamond and what's unique about diamond tools, then setup of parts and tools on the machine, various different cutting strategies, different ways that you can program, whether it's a paramacro programming or using CAM of various types, all the way through metrology and the feedback loop. Because one of the interesting things about diamond turning is just how short the feedback loop is. Like when you're working on a manual machine, the feedback loop is very, very close, right? Because you kind of can't make anything unless you're consistently measuring it, regularly measuring it throughout the process. Whereas on a CNC machine, there's a tendency to kind of give all of your inputs at the beginning, let the machine go, then at the end you check as a sort of a verification. But once you get to the very, very high precision stuff, then that feedback loop needs to get short again. And so there's lots of really interesting equipment that's used to keep that feedback loop stored. So lots of interesting metrology equipment like interferometers of various types. And so that whole package is something that I want to put together into a YouTube playlist that I think will be valuable. Like I haven't seen that anywhere else. I don't think anyone else has made it. I think like we're probably in a unique position to make something like that, because how many people have a diamond turning machine available to them and they don't need to make money with it, and they're not it's not hidden behind IP, right?
I think that's pretty awesome. So are you referring to, for example, diamond turning on the lathe and simultaneously having a interferometer looking at the surface? Is that what you mean? Or do you stop, you're going to stop that pass, take a measurement, do something or don't do something, and then go do another pass? How do you mean feedback?
Right. So there are ways to build the metrology onto the machine, and that's desirable, I guess, because then you don't have to remove the part. Our machine is not integrated that way. So we have to remove the part to go take it to an interferometer. That gives us very high quality data down to the nanometer of what the surface figure is looking like. So there are some things, some errors that we can, that we'll see through this method that tell us something about our setup, right? So like, let's say there was like a tiny little bit of debris or something hidden underneath the part when it went onto the vacuum chuck, right? That'll come up as like a little, like a localized high spot or low spot. So those kinds of things, or if there's an unbalanced condition, we'll get like a sort of a two lobe thing where there'll be like two highs and two lows, right? So there are various different diagnostics that we can run that way. But if there's just like an error in the form, which comes from, just the precision of the machine itself, there are other ways that you can fix that. So one of the things I'm really excited about is that with our new Zygo verifier interferometer, it will actually take the error data and you can spit it out as a point cloud in X, Z, C, really however many axes your machine has, you can get that information. And then you can put that back into the CAM software that we use, DiffSys, and it will subtract the error from the program, from the G code, and it will intentionally cut the wrong figure so that you have the right figure on the machine. So it's sort of like it's a way in the software of canceling out machine errors. That's something we weren't able to do before, but we can do now.
So let's pop up 20,000 feet, because I don't think many people have done diamond turning who are listening to this. So just talk to me like I'm a 63-year-old grumpy guy, okay? Describe diamond turning, how it relates to regular turning, which might be with high-speed steel or with carbide.
Yeah, I think probably the way to explain this is to go back to the way that optics are usually made. Because although diamond turning machines are used for mechanical devices, cutting all kinds of different things, it's primarily used for optics. So, in the old days and still today, right, like the typical way that you would make an optical surface, like out of glass or whatever, is that you would have to grind it, polish it, and then you would evaporate a layer of aluminum and maybe some like protective coating like silicon dioxide on the surface, and that's what it would be. Now that's about like 40 hours worth of work, and it touches many people's hands. It's also sort of like a non-deterministic process. You have a lap, and then you have the mirror, the glass blank or whatever it is, and you got to rub them together in exactly the right way, with the right conditions, the right slurry, the right micron grit, and then hopefully at the end of it, if you've got a really good process, then you'll have a good mirror or a good optic. With diamond turning, it's a very, very different way to approach it. So here, instead of having to take glass and then evaporate aluminum onto the surface to make it reflective, you could just start with a hunk of aluminum, because you can directly cut the optical surface into that piece of aluminum. And in order to do that, you use a CNC lathe. But it's a very, very, very accurate CNC lathe. It's got an air-bearing spindle, hydrostatic guideways. It's got, like a ruby diode laser reading a glass scale that has 127 nanometer native resolution, and then that can go down to like single angstroms through interpolation. So it's just a very, very high precision CNC lathe, and you can cut very precisely with it.
So is this a Vivor?
Yeah, exactly. No, there's like two companies that are the primary companies that make these diamond turning machines. There's More Nanotech, and then there's Precitech. Both of them kind of started from the same company, Pneumo Precision, back in the 80s. There are a few other companies now that are making these, like Toshiba makes a lot of them for the sort of Asian market. Innolite is a manufacturer that people may be familiar with. They're very, very innovative. So they're really kind of pushing all of the other companies to get off of their laurels, which is very interesting.
Yeah, one of our member of our community just became the president of Innolite.
Indeed,
Mr. Dan DeMazure. We're very happy to have gotten that news. More Nanotech, I believe, is a neighbor. I think they're up here in New Hampshire.
Yeah, they're in Keene.
Keene.
Both Precitech Nanotech are in Keene.
Yeah. If I drove from here to their front door, where I would, of course, be begging, that would only take an hour and a half. I think
Oh, I'm a little bit short. I've
well,
been planning a trip there.
well, you now have a hotel room. It's right over there. So you're welcome. So yeah, that would be a fun trip, wouldn't it? So
It would be.
how much does one of these commercially? How much does one of these lathes or the lathe that you're using would it cost for a company to
Well,
buy?
the one that we're using was made in 2009, and at that time, I actually saw the receipt because we got it as a donation from Lawrence Livermore National Laboratory, and when you do a donation, like an in-kind donation from one of these large national laboratories, research labs, there's a lot of paperwork, right? And so I got like a big packet of information by the end of it, and in there was the original receipt.
Wow.
And so it was $250,000, $250,000, which is actually surprisingly cheap in some ways
Well, it was also
for just how precise it is.
20, you said it was 2009. What was the year?
2009, $250,000. Yeah.
Okay. Well, it's more than a couple of bucks. It's not. It
More
ain't.
than a couple bucks, but like with how much tech is jammed in there,
Yeah.
you would think it would be more.
That's pretty cool.
Yeah.
So, are you
So
literally?
if I may, because the other part of this, right, diamond turning, part of it is the turning, so you need the really accurate lathe.
Right.
But then the other part is the diamond, and monocrystalline diamond is what's used as the tool. And the unique thing about diamond is, of course, that it's very, very hard. And so you can get it to atomic sharpness, where we've actually taken it into the molecular foundry at Lawrence Berkeley National Laboratory and looked at some of our tools under a microscope, and it's like you can just keep zooming in and it never gets dull. It's absolutely amazing. So it's very, very sharp. It also wicks heat away. Like, it's very efficient at transferring heat away. So that's another big benefit. But yeah, you really need both of those things. Like, I've seen people, like, you can cut with carbide on a diamond turning machine, and I've done that before, and it's a good surface, but it's not a mirror, right? And then you can also use diamond on a conventional machine tool, and you'll get something that's smooth, but it's not literally a mirror finish, right? Here we're keeping like surface roughness of less than 5 nanometers, and we can hold the form of an optical surface to something like, I don't know, like best we've ever accomplished was 50 nanometers in terms of the form.
Now, just because wavelengths are my language, the wavelength of light, visible light, the bottom of that is about 350 nanometers. 350 nanometers is very, very blue. It's when you start to run out of eyeballs. And you just said that you're holding 50 nanometers.
50 nanometers, yeah. So if you think of it, like, I usually think of it as green light, about 500 nanometers, which is smack dab in the middle of the spectrum.
Yep.
So if we take that as our guide, then we're about 1/10 of a wave.
That's
is
awesome.
50 nanometers.
And that's right off the lathe.
Right off the machine. There's no polishing afterward. You don't have to coat it. You don't have to do anything to it. It's just that good coming off.
That is amazing. Robin helps us. 25 nanometers, 25.4, I know, is 1 micro inch. So you're holding 2 micro inches.
Yeah.
2?
That sounds right.
Micro inches. I'm drooling a little. I'm sorry. Didn't mean to do that.
Yeah. It's pretty cool, man. Honestly, there's this, I don't know, you can probably think of like certain moments in your life where you got to see something firsthand and it just, like, your mind blew. Like, every single person who watches diamond turning for the first time, they see this sort of like matte machined finish turn into a perfect mirror. A perfect mirror. It's like a portal to another dimension. And it's like, on one side of the tool, it's gross. On the other side of the tool, it's a portal to another dimension. It's really amazing. Uniformly, everyone who's ever seen it in person is amazed by it.
I am looking forward to the opportunity to see that in person. And by the way, if you do want to go visit more, I we're going to have a road trip because I think that'd be great.
I have a state invite, so yeah, I'm sure I can bring a +1.
I am a +1. I'll even get a T-shirt that says +1, and I'll carry your bags. We have a couple of questions. First of all, where is he? Chris O says, I went to Laney 2014 to 2017. Really cool to learn about what you are doing with the machine tech program. There you go.
Awesome, man.
And Carl Tauber asks, do you sharpen diamond by grinding or cleaving?
Yeah, it's kind of grinding. So I believe the technical term, it's the same as for faceting gemstones. It's like scaving or something like that. But essentially, actually, a friend of mine who works for a diamond foundry gave me one of his cast iron diamond laps. It's just a big piece of cast iron, and you use diamond to sharpen the diamond, and it takes forever. But that's typically the way that they do it.
Wow. So that's very interesting. I'm going to have to just take the course. Dale is showing us a picture of a diamond tool, I guess off the shelf, a diamond insert. Very interesting.
Yeah, they make them in inserts now. They make them as like braised tools, which is usually what we use.
Yep. So when you buy the tools, you're buying literally a brazed tool. You have a shank, and then you have the diamond, or is it like a little insert with a hole in it, and then you have the diamond?
Yeah, it can be either one. But what we get is usually just like a solid chunk of diamond that's been brazed onto the end of a steel shank.
And what's the durability? Like in the picture we posted,
Yeah.
you have I don't know, what is that, a 5-inch diameter or a 4-inch diameter disc that you're turning?
It's 100 millimeters, so it's like roughly 4 inches.
Okay, so would your insert just happily do that whole project and do another 5 of them, or?
Oh yeah.
Okay.
Yeah. I mean, it depends a lot on the material that you're cutting, but like, if it's brass, OFHC, copper, aluminum, those kinds of things, they machine extremely easily. And so, you'll get a whole bunch of parts out of a single tool. The problem is that, the diamond needs to be, again, atomically sharp. So if it's even slightly dull, then it's not usable anymore. You know what I mean? So like, even though you could continue cutting like for days and days and days, right? Like at some point, your surface finish isn't coming out within spec. So like that tool just needs to be relapped. And you'll buy the tool for like $500 or something like that, but then to get it relapped is only like $50, and you just send it back to the manufacturer, and they turn it around super fast.
Okay, so they were also providing a service in addition to selling you the tool, and that makes sense because it's such a specialized thing. Stan Workshop asks, is it unsuitable for stainless steel?
Yeah, unfortunately, this is one of the great ironies maybe of diamond turning, because the things that you would like to, like, immediately you're thinking like, okay, we've got this great fast way to produce optical quality surfaces. Like, I know exactly what I want to do. I want to cut some glass and I want to cut some steel. And those are like the two things that you can't cut. So I don't know why you can't do glass, honestly. Like, that one's a little bit of a mystery to me. But the issue with cutting steel actually is pretty well known. So like anything that uses iron as a base, because the diamond is carbon, and essentially what happens is that there's so much heat at the point of the cut that the diamond actually starts to break down chemically and diffuses into the iron. So it's almost like, yeah, I mean, it's almost like you're like case hardening the part, like as you're like dumping, it basically breaks down into graphite and diffuses into the material.
I was trying to come up with a really simple analogy, mostly because that's how my brain understands things. And that is, it's like using a sugar cube to cut an ice cube. And that works pretty good until until the pressures and the heat gets a little high, and it starts melting, and the sugar melts right into the water, and everything melts together. And the diamond chemically really wants to go get dissolved into the steel, just like in my really bad example, that the sugar really wants to get dissolved into the water. And but if you go really slow, you can do it. And
Yeah.
that's why we can do a diamond lap on a steel thing by hand, but you fire it up on the surface grinder and say bye-bye to your nice diamond wheel. Robin says,
Yeah, that's right. Using a hunk of steel is actually a great way to dress a diamond grinding wheel.
it is. Well,
Yeah.
I would take exception to the word great, but yes, it is a. So you know who showed that is Solid Rock Machining. He showed using
Okay.
a steel plate to true a diamond wheel, which is awesome. And of course, I use and sell. Okay, it's a commercial. Molybdenum, and there's an old 1973 patent on using molybdenum to true diamond wheels, but it has to be done at roughly I'm doing this by memory, 700 surface feet per minute. So you have to slow your wheel down. And then,
interesting.
And then Robin one day called it galling, and it's on my list of things to see if it is galling, but basically it's the mud puddle that you're running through with your galoshes. And if you run through the mud puddle at just the right speed, the galoshes will get sucked off by the mud puddle. That's my mental model of how molybdenum yanks diamonds out of the matrix. But I digress.
Wow. What a colorful description.
It's the only way my brain works. I didn't want to scare you. it's sorry.
A funny, kind of an interesting story. Very recently, one of my students tried to dress a diamond grinding wheel, like a resin bonded diamond grinding wheel, with a typical diamond dresser. And it turns out that what happens is that it grinds the dresser. So diamond.
Oh yeah,
diamond.
yeah.
And we made a very, very nice little facet on that diamond dresser.
It gets weird when everything's the same. Who's going to win? It's a good question. Let's see. I think we answered Stan Workshop's question quite well. Robin said, while we were talking about the way you turn things, he said, except Inolite. Can you clarify that, Robin? Because I lost the context on that. And Paul says...
Well, I'm sure he's talking about the ultrasonic assisted machining.
Oh, okay.
Yeah, they're not the only ones who do it,
Okay.
but they are. Yeah, they're like one of the big ones. There's also laser assisted diamond machining. So, like with the ultrasonic, you have this little like piezo. It's like a little tuning fork, and on the end of it, you've got the diamond tool, and there's a little piezo actuator, and it's like 100 kilohertz or something. And this tool is making this tiny little elliptical pathway.
Mm-hmm.
And I think it goes like 2 microns at a time or something like that. And so kind of like the issue before was that, right, you need 3 things in order to get the diamond to break down. You need heat, you need pressure, and you need time. If you break any one of those things, it's like a fire, right? A fire needs 3 things. If you take away any of those 3 things, you don't have a fire. It's the same thing here, right? And so the ultrasonic, it basically just breaks the time, right? So then it doesn't break down. So then you can do steel. Actually, I think the biggest thing that they're excited about with those tools is turning invar, because there's a lot of situations where you need a high energy laser, and especially when they're trying to they do a lot of free forms, and so they. Okay, yeah, I guess there are like 2 main things that they use that for. But one is using invar, and so they do these freeform mirrors, and they're using high energy lasers to basically apply like a certain type of a heat profile onto parts. They use it in semiconductor quite a lot. So that's one that they're using it for. And then the other is, turning like P20 or something like that, some kind of like a nice mold steel for doing mold inserts. A lot of times for like automotive, like headlights and that kind of stuff is oftentimes diamond turned into, like, before they were diamond turning it into aluminum, but those aluminum mold inserts don't last very long. So of course you'd like to do it in some kind of a mold steel.
Wow. I'm digging the idea of the piezo control of the tip and getting an elliptical motion out of it.
It's pretty cool.
That's pretty neat.
And there was a time when we got one from Innolite.
Yeah.
But in the time frame that we had gotten it, we couldn't do anything with it because we're just way too busy.
Yeah.
So we ended up sending it back, unfortunately. But I'm hoping, especially with the new president at Innolite.
I've heard of him. Yeah.
Yeah.
Yeah. I need to buy that guy lunch. Hey, and Dan, you're welcome to come on the PFG Live and talk about Innolite. I think that would be also cool. Wouldn't that be cool?
It'd be super cool.
That'd be really cool. Robin says 36% nickel content of Invar makes it easier. Yeah, it probably does. So Invar actually popped into my head earlier when you were talking about, different diamond turning different materials, because it doesn't have the temperature coefficient of thermal expansion that, a steel or an aluminum would have. So that sounds like it might be an interesting thing to try to make a mirror out of.
Agreed.
We're on it.
If you can find a giant, like a 10-inch or something, Invar bling, those things are not.
Oh, Dale. I'm looking at you, Dale. Yeah, there he is.
Have Invar?
He says Robin throws around easier like I do. So, yeah, Dale does some exotics in the work he does, and I think Invar might have crossed his threshold. We'll talk. We'll maybe get you a chunk of something to play with. So one of the things that super impressed me about how you're running your program is the telescope project. And I was just bragging about you this past week to someone, and I said, oh yeah, this guy's running this program and he teaches the kids, and they make kids. I recognize it's kids of all ages, okay? But he teaches the kids how to make a telescope, and they make a telescope. And my friend who I was talking to said, oh yeah, that's pretty good. I said, no, excuse me. I don't think you understand. There are no McMaster car part numbers harmed in the making of this telescope. Everything is made. The mirror is. So talk a little about the telescope program, because I think it's a phenomenal teaching tool.
Yeah, this is like my favorite topic to talk about.
Folks, we're going late, folks. Just want you to know you might want to schedule.
We've got so much content out there now about it. Like we've got a news article, we've got 2 separate videos about it. So I can, and then like most of my most of the department's Instagram account has been dedicated to that project for some time now. So I sort of dumped everything that I had into that thing, and to the point where I used to do all these really fun side projects. And all of my side projects just became that telescope. And so that's like where all of my energy goes. Because there's like all this fine tuning, as you can imagine, there's all this fine tuning that goes into the process for that. But the telescope it's what we make now, what students make now as their project throughout the course sequence in the program. So in every class, they're learning what they need to learn at that level in context of making parts for the telescope. So every class donates essentially like one sub-assembly to the larger scope. And at the end of the entire program sequence, then they get this like 4-inch, 100-millimeter Cassegrain telescope, which is actually really cool. It's got some really neat features on it, lots of different like flexural mounts. It's like a sort of open truss tube style telescope, which means that it doesn't have like a shroud over it, so you can see everything on the inside. It has these carbon fiber rods that connect the two ends of the telescope to each other. There's in the very, very first class, they make what's called the finder scope, which is this like relatively low magnification, kind of like a binocular. It's like 6x magnification, but it's this little finder scope that attaches to the side of the larger telescope. So that's what they do in the very first class. And then in every subsequent class, they make other parts. And it sort of culminates in machining 214, which is that class where we do both diamond turning and micro milling.
It's so awesome. I cannot express how awesome that is. So are they making the lenses for the little telescope, the finder telescope?
No. So are you familiar with surplusshed.com?
Unfortunately, I am.
Yeah. I said, despite how inexpensive their stuff is, I have wasted thousands upon thousands of dollars. Well, so I found out that that they had exactly, because they have a lot of like old World War II binocular stuff. So I basically bought the achromatic objectives for this one particular binocular set. So they had a bunch of surplus lens elements. And I bought like 150 the first time. We loved them. They work great. So I was like, how many more of these do you have? It's like, well, I've got 350 of each. So I'm like, I'll just take them all. So we liquidated Fred's entire stock of these binocular lenses. So if anyone out there was trying to make one, I'm really sorry.
Too bad. How far away are those guys from you? They're in California, right?
Surplus Shed? No, they're over by you.
Oh.
I think they're in like Pennsylvania.
It's closer, but it's not dangerously close. Okay.
Not dangerously close. No, but it's closer than California.
Yeah. Interesting.
I will say that, actually one really cool thing is that it seems like a bunch of interesting people are moving out to the Bay Area. So we got Matt Halpern, Extra Minty Matt, recently about a ago moved out. So he's working at Zygo, and he's been coming over on Fridays, and we're working out a process to make some lenses, and we're going to be doing a sort of conventional lens making workshop that will hopefully turn into a course. And the ultimate goal, I think, is to start making the lenses for the finder scope. I think that would be nice, especially because we're going to run out of them eventually, and it's just a cool way to kind of, I don't know,
close the loop,
complete that circle, right? Close the loop, right?
I've been trying to get Extra Minty Matt on the PFG.Live for a while. I'd like to poke him again. Yeah. I think the whole optics, the making of optics is interesting to me. And of course, diamond turning is, by definition, you're making optics. But glass lenses is very interesting. And Extra Minty Matt is like, he cranks out lenses like we crank out blivets, what do they call those things? Fidget spinners. That's it. He cranks out lenses like we crank out fidget spinners. So I'd like to talk to him more about that.
It's so interesting to see the way that his brain works, because with machining, I think we tend to be a pretty like cerebral bunch in some ways, right? There's just like, we do a lot of things by numbers. We're very like focused on, we read a lot. There's a lot of, data that we're using. We usually process things numerically, right? Using computer control. And in optics, it's like very much the opposite, right? It's like, there's no data tables anywhere. Like, it's all just based off of trial and error, what has worked, what has gotten passed down through the generations. It's like tribal knowledge. Mm-hmm. And just like, seeing the way that he figures out a process is just like, I don't know, let's just like put these things together and let's see if it works. Oh, that didn't work. Okay, maybe I just, maybe I scored the pitch on the lap this way instead of this way. Let's try a different way now.
Yeah.
But all those things matter, and like, it doesn't make sense to me at all why any of those things would matter. But it clearly makes sense to him, and it clearly works. This guy is like, okay, so for our Zygo verifier, right, there is a reference optic that's used with the verifier. And this reference optic, it's like it's the thing that you're comparing the test optic directly to.
Yeah.
So it needs to be as perfect as possible. So like 1/20th wave is a minimum, and sometimes they'll get even better than that, like 1/100th wave for like the really really expensive ones. Well, he's the guy who makes those. So I mean, like he's
Yeah.
at the very very top of his game.
That's awesome. That is awesome. I mean, I focus on flat. The fact that somebody's focusing on getting the curve right is like that's a whole other dimension. I'm off on Wednesday.
Yeah, you're cutting, or you're trying to lap metals, right? Like steel and
Yes.
I guess the
Yes.
Yeah. Those are much more difficult to grind and polish than glass, right? Like brittle materials are way easier to grind and polish.
I have so much to learn, but I also don't have a customer asking me to grind something made out of glass, but I do have a customer asking me to, I said grind, I mean lap something made out of steel. I'm off on Wednesday to a company to purchase a 8-inch double-sided 1/1,000,000th of an inch quartz lap to support a project.
Quartz lap?
Optical flat. Sorry, I said lap. I didn't mean that. Optical flat. So that's going to be. Say again?
For testing.
Yes, for measurement. Exactly. Everything I've had has been surplus. And now it's like, no, you actually have to make a measurement, sir. Like, okay, got it. Write the check. I understand. So that's happening this week.
That's a tough one, right? Because that's like, again, that's your reference optic. That needs to be as close to perfect as possible. So how do you verify that it's perfect?
So
I mean, they're waiting for it, but it'd be nice if you somebody else to verify it.
I'll name names because I think these guys are cool. Dale says with your checkbook. That's correct, Dale. This is a company called, I've never been there, haven't done business with them yet, called Russell Optics. They're up in Vermont, sleepy little Vermont, little quiet town, which I was familiar with because I've flown over it in my glider. And my customer says, oh, you should go see Russell Optics. And I'm like, really? Okay. So I get on the doobly-doo and I look these guys up. And I'm like, oh, these guys are cool. They are making lenses and making flats and they have, and the key point was they'll make me an optical flat and it's traceable to NIST with a certificate. Okay. And they do it like it's making a sandwich. What do you want on your sandwich? You want mustard on that? Okay. Do you want pickles? Yeah, we have one on the shelf that's got mustard and pickles. And I'm like, yeah, that's what I want. Okay, it'll be here for you. Like, what a holy cow. And the specification is 1/1,000,000th of an inch. And I can't wait to get my hand. I'm
over 8 inches?
8 inches, yeah. I learned my lesson because Robin says it should have an interferogram with it. You bet your buns we will have an interferogram with that, Robin. So I told these guys I'm coming to get it. I do not ship. So my son Jared and I are getting in the car on Wednesday, and we are driving up to Vermont to pick up the thing, and I'm going to make Jared carry it the whole way back.
Pretty cool. You know how thick that flat is?
I don't remember. I know how thick the check is. It's about 4/1000ths.
Measuring something that's 8 inches in diameter, right, and is made out of glass, which is relatively heavy.
Yep.
Right, measuring something like that to 1/1,000th of an inch, let alone getting it to repeat within 1/1,000th of an inch, is really challenging. So they, that's really that's hard to do. I'm not sure how they're doing it.
So Robin says that is standard 1/10th band flat. So yeah, ballpark price, Mr. Morley, is about $3,500. Dale just posted their price list. That's the other thing is, you call these guys up and it's like, oh, just look at our price list. And you look at the price list and it says, oh yeah, you want a 10-inch? Do you want it one-sided or two-sided? Do you want it coated with titanium oxide? Here's the price. It's like McDonald's. It's awesome. So I have been thinking about how to, first of all, I started with my little 1-inch things. Then I made my 3-inch things. I thought I discovered America. And now I have to make 6-inch things. So now I have to spend money because I need to get this 8-inch flat. And I've been thinking a lot about handling, like your warm lunch hooks touching the flat, touching the work. You have to do thermal management. You have to do, you have to lift something that actually is going to be heavy and not screw it up. So there's all these things that are going through my mind for process development, which one of these days we'll make a video about. But it's going to be interesting.
One of the issues that happens when you have a flat of that size is that it's so heavy. And, glass is not particularly stiff.
Mm-hmm.
So if you were to set this optical flat down on top of your test piece, it's going to bend a little bit,
mm-hmm.
right? And to some degree, it's going to bend to conform to the shape of the optic that you're testing. That's one thing that you need to be aware of, I think.
Thank you. You just caused me to lose a little more sleep. I appreciate that. Yeah, it's going to be interesting. And my customers' requirements are stiff, but not insane. So I think we're going to be able to do it. Robin says the flat is fused. Yeah, we keep saying glass. You are correct. It is fused quartz for starters. And also, Robin points out titanium dioxide gives a really crisp bands on non-shiny parts, which I think is what you were trying to say. Yep, fused quartz. Anyway, I will report back, but this company sounds like a worthy vendor, and if I'm right, it's going to be a happy relationship.
Awesome, man. Are you going to share all your tips and tricks?
Of course. I try. In fact, one of the things I came up with, so you may recall I made these 6-inch laps,
mm-hmm.
and I used some ideas from Robin in putting a moat around it so that you don't lose all your slurry, which was a very good tip. And then I did a bunch of stuff. Well, now I'm thinking about these 8-inch laps that I have to make, and I've come up with some ideas about different ways to make the grooves in the laps that may be a little better, which I got to work out the design, but if that works out, I'll share that to the community. And also one of the things that I demonstrated before, which I kind of have bits and pieces laying around, is making 3D printed holders for the items for thermal isolation and for force direction. In other words, where do you want to be pushing on stuff when you're lapping? So and Robin had some ideas in the past on some small widgets where he goes down with a little blade and pushes way low, so you're not tipping. I mean, there's all these very interesting problems to solve that, like you were pointing out with extra minty mats, some of them don't have numbers associated with them. It's just this feel and procedure and stand on your left foot while you push with your right hand, and it's pretty cool.
Yeah, it's also like very specific to the person who's doing it and the environment that they're in, right? Because like human beings are not like perfect machines, right? So we have these like linkages that are really not designed to go in straight lines, and so just exactly the way that you stroke a part over a lap will have a different effect than somebody else doing ostensibly the same motion, right? And so like this is the downside of trying to do this by hand, right? Rather than using a machine. Because with using a machine, you're in direct control of all the parameters.
Yep. Well, I watch, some of the stuff that Matt posts, and I'm like, oh, it would be so cool to have one of these lapping machines and you could program it up. It's like, well, if I'm going to do a half a dozen parts a year, I think I need to stick with hand lapping and the human in the loop feedback. If I was doing 100 of these things a year or something, okay, I should dedicate N square feet in my shop to a machine. So it's like you said, it's a boutique-y thing, and once you learn how to do it, it's like grandmother's recipe for making the roast. You know that story? I've been following the grandmother's recipe, and you have to cut off the ends flat, and then you have to use these spices and everything. And one day, one of the kids says, "Well, Mom, why do you have to cut the flats on the side of the roast?" And Mom says, "Well, it's because Grandma taught me that. And we just follow Grandma's recipe." So the kid goes to Grandma and says, "Grandma, how come you taught Mom to cut the ends off the roasts?" And she says, "Because my pan was too small." So we develop these little tricks, but then if we try to teach the little tricks to somebody else, they say, "Well, you have to do it." Anyway.
Yeah, no, it's a perfect analogy.
Yeah.
Perfect analogy. Especially the sort of, so what gets lost in that game of telephone, right? Like if you just kind of follow a recipe, like in a sort of ritualistic way, right?
Mm-hmm.
Assuming, like it's going to get you the same results, hopefully, but you're not really thinking about why you're doing any individual.
So to me, you have to be able to measure it, and you have to have a notebook. And if you can measure it and you have a notebook, you can get the feedback loop going and say, "Oh, that worked, that didn't work." And eventually you come up with this recipe. If you leave out the notebook, you're hosed. And if you leave out the reference, you don't have a way to measure your hosed. So I have a notebook, and I'm about to buy an 8-inch optical flat. And hopefully we'll figure this out.
Before long, you'll be there thinking like, "Oh, I cut the groove this way instead of this way," so you know exactly.
Oh, that's already started. I haven't made the laps yet. It's already starting. It's like, wait a minute, hang on. What if I?
Yes.
Yeah, no, it's already happening. So let's get back to the telescopes. Have you had? Oh, here we go. Robin says, understanding why is everything. Striving to be aware of all the whys is the fun. Yep, that's why they call it whys, Robin. Okay, so what kind of feedback have you gotten from the students on their telescopes?
Yeah, it's been very good. Like students are very motivated by it. They're very excited about it. It's a very demanding project. I set very high expectations for folks. So it's up to them to rise to that occasion, and for the most part, they do. I think that they're getting a lot more done now than they had been in the past. Partially because there's more resources available to them now, but also because I think they're just more motivated by what it is that they're doing.
Mm-hmm.
So it's been really good. I think that the first group who started 2 years ago and is now finishing the program sequence since we started the telescope project, I think the first group now after this summer is going to have a finished telescope. So that'll be very exciting. One of the things I'd really like to do is have some kind of a celebration for all the folks who finished their telescopes. Like one of the things I'd really like to do, I had a mentor named Jim Galvin who kind of got me into optics of all time. He was my mentor at Berkeley Lab. And his thing was that for several decades, he would always spend a month in Death Valley at Stovepipe Wells. And he would go out there and he became such a fixture. He would always bring out his telescopes and his microscopes, and he became such a fixture of that spot that they ended up, letting him stay for free as long as he would, I don't know, do like popular science stuff for all the visitors.
Yeah.
So in honor of him, he passed away a few years ago. But in honor of him, I wanted to do like a caravan out to Death Valley and bring all of the Laney scopes. And I think that would be a fun thing for everybody.
That would be awesome. We will require video, of course. We had a couple of questions pop in. I don't want to. Carl Tauber points out that Marv Grow developed techniques for machining single crystals in the ductile regime. If you want to diamond turn glass, you should talk with him. Thank you. I do remember him doing some of that stuff. Greenwood AG asks, can CBN be sharpened enough to use on one of the diamond turning lathes?
I mean, you can use carbide on a diamond turning machine. You're not going to get the same quality of result. It's just not possible to do.
Okay.
But yeah, then you could, with carbide, you can cut practically everything. With CBN, you could do hard turning. I think the machine that we have is not quite set up to do hard turning. So I think we probably couldn't do very much of it, meaning that like it would have to be really, really light cuts, and I don't think it would like it very much. But I think that some of the more nanotechs are a little bit beefier, so you could probably do hard turning there. In fact, I seem to remember that they were doing some hard turning at Lawrence Livermore National Laboratory on some really, really hard refractory metal alloys, but I can't remember now.
Okay. Let's see. Okay, so you also brought up, and we only have a few minutes because we've hit the top of the hour. You brought up micromachining as specific, distinct from diamond turning. What's going on with that?
Yeah, if I may.
Yes, you may.
I brought some show and tell. So let me quickly walk you through like what it is. One of the things that we do on the diamond turning side, and one of the things that we do on the micromilling side. So, so this is the water jet cut blank for the primary mirror of the telescope. Okay, so this gets water jet cut out, and then it gets CNC machined to rough shape. And then one of the things that we need to, there's two things that we're going to change this semester or this summer to make this better. So one is that we're going to introduce a thermal cycling process to heat stabilize these parts. Because we notice that there's just like a lot of stresses built into this material, a lot of stresses, especially after machining. So we're going to do probably like a three cycle process. So we'll take it up to like 300 degrees Fahrenheit, go down to like dry ice temperatures, and repeat that 3 times. And that's a pretty well-known recipe for stabilizing 6061. So we're going to do that, and then it gets diamond turned, and it looks like this. Looks like that.
Wow! Look at that. That is awesome.
And you can see all the crud in this room right now. Kind of embarrassing.
that is.
But yeah, so
incredible.
this is after diamond turning. So one thing about this, though, I don't know if I put this on its edge, maybe you can kind of see that there's some corrosion on that surface.
Oh yeah, I saw a little smudge.
Yeah, and so this is actually the one that I had first made, and we're using it as kind of like an example piece. And so this one actually spent a few nights with me out camping, and we were using it to look at the moon and planet and stuff. And it turns out that aluminum, hey, is not very corrosion resistant when there is like actual water in the atmosphere. So we now partnered up with a company in Arizona, Arizona Thin Films, who's agreed to do some optical coating at the very end of the process. So they're going to deposit a thin layer of pure aluminum and then a thin layer of silicon dioxide as a sort of a protectant.
Wow.
So those are the two big things that we're changing. Are we're coating the mirrors now, and we're doing the thermal cycling, and I think that's going to make a big difference.
Well, that's awesome.
So there's that, and then on the micro milling side, this is whoop,
Okay, hang on. Of all the
it
words,
was
of all the words we should use in micromachining, oops is not one of them.
oops.
Oops.
Yeah. Well, it was precise a moment ago. Anyway, so what we do is we take these commercially available indicators here, and
Yeah.
then we turn them into this. So we
That,
do, well, we do quite a lot on these actually.
that's
I wish that
beautiful.
eventually we'll make our own indicators from scratch, but for now we just don't have enough time. So we're doing,
Yeah.
kind of the way that it would have been done back in the day for a watchmaking masterclass, where they would take an existing watch and then they would break it down, and then they would reverse engineer the main plate and bridge components, and then they would do some kind of special work on that. And so we're essentially treating it the same way, right? So they start by disassembling this, reverse engineering it. They remachine the main plate. They make the bridge pieces. We were cutting the jewels out of carbide, so we're using some 6C tools, high flute PCD cutters to cut some carbide jewels.
Nice.
Yeah, and then they're also skeletonizing
That's beautiful.
the main plate.
I
Yeah,
love
it's
the I
really
love
cool.
the idea of putting the clear plastic on the back.
Well, yeah, you gotta,
You
right?
gotta. Yeah, it's like a
Display.
absolutely. Is that plexiglass or is that something harder?
It's acrylic.
Okay.
Yeah,
I won't ask for the
yeah.
the chemical formula. That is pretty
There's so
cool.
much. There's so much that goes into this. Like where just again you have to keep the feedback loop really close. We're trying to hold everything to like just a couple microns.
Mm.
And so we are making heavy use of modular work holding, especially like System 3R, and we recently got a what is it? It's the Flux Work Holdings puck system. Yeah, you know the one I'm talking about.
Yes, I actually do. Yep.
It's like it's aluminum, but it's like a Hearth coupling design. It's really really neat actually, and we're going to try
Yeah.
that out.
That's neat.
But we're essentially like moving it from the machine to the CMM. We have a Zeiss Duramax to the CMM, check it, move it back to the machine. Like you have to keep that feedback loop really really short in order to
Mm-hmm.
achieve the kind of tolerances for. Also, getting to use a measuring microscope. Yeah, and at the end of it, students, a lot of the micromilling stuff is like relatively simple geometries, but just done to very high precision.
Yep.
So that's kind of where we're coming from on this one too. But a lot of times, like if you ever talk to someone in industry who says that they can work to tenths,
Yeah.
meaning like a 10,000th of an inch, like I can almost guarantee you that they don't know how to work to tenths, because what it means to actually nail like 2 micron is, I mean, it's not what most people think it is. There's a whole lot there that if you're measuring that with a micrometer, you're not measuring tenths. There's so much more that goes into that.
What kind of thinking do you do about thermal growth and thermal effect of handling parts? And are the students learning about that? And are they controlling that?
I mean, they learn about that, but there's no way to not learn about that because it,
Yeah.
it comes up as you start handling things. Um, so, even just like wearing nitrile gloves is a pretty good way to create a kind of a heat barrier.
Yeah.
And, so that will conduct heat into the part a lot slower. So even that will help a lot. One thing that you can do, especially when you go to the measurement stage, is just put it up on the interferometer or whatever, and just wait a while for it to soak in. Like luckily, the entire part is made out of aluminum, so it doesn't take very long
Yep.
for it to stabilize. And then the parts that are coming off of the kern are relatively small, and so it really doesn't make that big of a difference there either. And again, that's like aluminum and brass in those cases as well. So yeah, it's not so much about absolute temperature changes as it is about temperature variation
Mm-hmm.
over a part, right? Where you get like localized distortion. So that's the kind of thing that we're trying to minimize. But what I've been amazed by is how little, a few degrees up and down just in the average, in the environment as a whole, how little that actually affects the process. I think mostly because we are not set up to do like large batches or automation, and we're essentially setting up the machines right before we take our cuts, and the cycle times on those cuts are pretty short, so it really doesn't make a big difference. Which is, I wasn't even sure that we would be able to, like in our environment, I wasn't sure that we'd be able to accomplish the kind of precision that we are in fact able to accomplish. So it's been a very nice surprise.
That is awesome. I want to give a shout out to Hassan, who posted a couple of pictures in the chat. One showing a lap, which looks mighty familiar. It looks like the exact thing we learned from Robin, putting the moat around the outside of the lap. But he also shows a 3D printed isolator, which is excellent. So good job, Hassan. So I want to switch briefly to the human element solidly. Have any of the, well, no, let me put it this way. Are there any students that you can imagine, without naming names, of course, that just had a complete breakthrough by taking your course?
The diamond turning course?
Any of your courses?
Oh yeah, for sure. That's a regular occurrence. There's also, like, you'll have occasionally students who, that they'll make it through one course and they'll say, like, you know what, I'm glad that I learned that, but I don't really want to do this for a living, because
Well, that's
it's quite
good.
stressful, right? A lot riding on your shoulders.
Yeah.
So and that happens too, but usually it's a very good experience. And I always enjoy when students sign up for the class not knowing what to expect, and then by the end of it, they're like committed to a career in machining. That's always cool to see.
So you've had how many of those have you had, where like the gems, the students that are like completely bought in?
Completely bought in. I don't know. So like if I take the introductory class, there's like 25 people in each one of those classes, and I would say a good solid 10 of them by the end of it are really bought into it.
That's cool.
Yeah,
That's cool. I mean, if you said 2 or 3, I'd be tickled. But that's a good number. That's a good number. And
yeah, and there are other who kind of come in and out, or that they're still not sure, but they want to continue into the second class to see if it's something they like. Or in the first class they're doing a lot of manual machining, so sometimes they'll veer off and they'll go into CNC, because we make everyone take that first class. But then after that, they can kind of choose their own adventure, and so sometimes they'll just go straight into CNC, and then they really, really love that.
That's pretty awesome. Let's see. We had a question. Chris O, who was at Laney, we learned, says, I heard a story from one of my coworkers that said that some of the older Raytheon engineers used to only braze in one of the vacuum furnaces because that one was magic and always made good parts. When he goes home, what is the shape of the roast that his wife makes? Just curious. Do they cut the ends off? Let's see. Bart says, what are your thoughts on teaching basic machining online? Ever consider doing that to reach a larger podium? Pros and cons, says Bart.
I mean, that's kind of what YouTube is, right? I mean, there's no shortage of basic machining content out there, and being able to sort through it can be a challenge if you don't kind of already know what makes sense and what doesn't. But there's more than enough stuff out there. One idea is that this is why I'm sort of ideologically committed to this basic diamond turning training. Because I think that is something that doesn't exist out there, but it's every day it's becoming a bigger and bigger part of the industry. So I think it's worthwhile to have something like that out there. One idea that I did have that I've been kind of playing around with is, like, I don't see I don't see any basic machining content out there that really starts from like first principles. It usually follows like either it's purely project based, or it usually follows your typical textbook approach to teaching machining, which is sort of there's this like menagerie of different tools and techniques that you need to learn. And so it kind of like gives you like a list of all those things and shows you how to use those tools. But I really like the first principles approach. It's the way that that I think I learned from best, which is like you take it all the way back down to the very, very most fundamental basics, and it's almost like, you know, like the origins of precision. Like where does precision come from? Like it's almost like following a historical development
Mm-hmm.
of precision in a way. And if you build up your skills on those original foundations. And I use the word foundations purposefully here, right? Because this is essentially the approach taken by the Moore book, Foundations of Mechanical Accuracy.
Mm-hmm.
But there's quite a lot. There's a lot of other books as well that go into this, and there would need to be a lot more that goes into it. But I think that's an effective way to teach people, or at least way to teach a certain type of person who wants that background knowledge. So that was another thing. Like if I was going to spend time making YouTube content, that I would try to create some kind of a structured playlist that follows that kind of curriculum.
Have you read the book The Perfectionists?
Yeah, the Simon Winchester book, that's a great one.
Okay. Because as soon as you said that, it's like, that would be a great course outline. First, we're gonna drill a hole to within 1/8 of an inch. That's the first thing we're gonna do in the course, or bore a hole within 1/8 of an inch.
In a way, it kind of sounds like the stereotypical story that you hear of like the German masters would like force their apprentices to file a 25 millimeter cube or something like that,
Yeah.
and it would have to be accurate 1/10 of a thousandth of an inch. Sorry, 0.0025 millimeters.
We're with you. It's okay. It's all right.
Yeah, it sounds tortuous, but I feel like in some ways that's what's lacking. And there are some students that I come across who like watching a YouTube video and then trying to make something based off that YouTube video, kind of like a paint by numbers kind of approach to it is really what they want. And I think that's more or less the way that people are used to learning these days. But there's another type of student, I think the student that I more identify with, that is closer to the way that I learn, where they really want to explore the depths of something, right? Because if you keep asking those questions like why do we do it like this? Why? And eventually you get down to, okay, blank slate, you're on a desert island, like how do you make a lake? You know what I mean?
Right.
And that's where the interesting thing about machining is working your way up to that. Although it takes a lot longer, right? And like your boss at your CNC job shop isn't going to want you over there like, lapping 3 plates using the Whitworth method.
Mr.
A little bit ridiculous.
That's right. Mr. Whitworth, what are you doing?
Yeah.
I think that, but maybe that's a parallel branch. It's like, oh, you want to jump on the learn how to run the machines, make parts, get a job, and okay, that's this branch. But it's like, no, I want to go from zero to smelting my iron, making my cube. That would be a very interesting parallel track for those that are maybe more detail oriented. That's not the right word.
It's like a way to, I swear we talked about this like one of the other times that I was on, but what I'm proposing here is kind of a way of taking like machining knowledge and like making it sort of a linear progression for knowledge acquisition. Kind of building intuition first, setting the intuition first, and then building up from there. But I think it's kind of a substitution for the way that I think we actually learn, which is that like in school you get like this basic. It's essentially you get like a glossary, right? Like this is this tool, this is that tool,
right.
This is this technique, this is that technique, this is this machine, this is that machine. Where you get a glossary. and then you actually have to go to work and you have to put it all together. And so what ends up happening is that like every day you learn a little thing, right? And then the longer you stay in the trade, the more little things you know, right? And at some point you need to be able to like draw dots, or draw lines rather, between all those, like in some cases seemingly disparate little like tidbits, right? So that's what we call constellative learning, right? Because you've got a bunch of like seemingly random pieces of information, then your brain makes constellations out of those little, stars of knowledge.
My brain does it.
And so that
My brain does it with red yarn. I can't explain that, but
yeah, it's the conspiracy theory, like learning style. I think that's kind of how we actually learn, and it's a great way to learn. But it would be nice too if there was a condensed version of that you could take as more of a linear progression. And again, I don't know if like everyone would buy into it. You've got to already be pretty sold on the basic, like you have to know that this is what you want to do, and you want to invest a bunch of time in learning what somebody else thinks you should learn as the foundations of your craft.
I'm going to sleep on that tonight. And I'm going to buy a whole bunch of red yarn and start putting it together. Last couple of questions. Hey, Adam, love the first installments of your autocollimator series. Any chance there will be a finale? That's from David Novak.
Yeah, well, I have a whole bunch of series that I need to finish. I have an air bearing series that I need to finish. I have an autocollimator series that I need to finish. And then there's another one. Yeah, how long ago was that? It was like 4 years ago that I made those videos.
I don't know. And also in the same sense, Paul Morley says, I've always thought your angle plate demo part 1 video on the Classroom channel is really close to the first principles idea. Love those videos, he says.
Thanks, man.
Ted Hyde says April 2021 was apparently your autocollimator series.
Yep, that was a long time ago, man.
Well,
I mean, just so that I can get people to stop asking me about it, I should go back in it.
That would work.
I would really, because it is like, it's kind of hanging around my neck like an albatross at this point.
Well, you're hanging around a bunch of completionists here, so we're really interested to see. Yeah. I have 2 series. I shouldn't even bring it up. I have a couple myself that I have to bring in for a landing. Hey, listen, we could do this for another 3 hours. I want to say thank you very, very much for coming on. It's always a pleasure. We learn from you, and we like the fact that you're a good educator and you're teaching the youngins, and we appreciate that.
Thanks for calling me out, man.
Oh, we'll call you out. Don't worry. All right. Well, thank you so much for being here. I'm going to wrap this up. Are you willing to come back?
Yeah, of course, whenever.
Okay. I just want to make sure we didn't damage you or anything.
No, it was fun.
You're awesome, and we'll keep going. Now, we usually pop over to the After Party Roundtable channel, and that's where we have the finger sandwiches, including those little lobster things you like. So as soon as we wrap up here on this channel, we're going to be over in the After Party Roundtable. And let me just say thank you again for being here. And then I'm going to do a quick commercial, and we're going to be done. Thank you, Adam. All right. Thanks. So we're going to... That was awesome. Wasn't that awesome? So don't forget, Adam's Instagram is Laney Machine Tech on Instagram. His YouTube channel is somewhere. We'll find it. Don't worry. We'll tell you about it. If you need some flat items to make some other flat items, head over to PFG.Stones.com. If you want to join us in the McMaster-Carr catalog giveaway, head over to pfg.gg/links and look for the great big red button right in your face. And you could put your name on the list. What else? I think we covered everything. Adam was awesome, and we're looking forward to picking his brain some more. There it is. Josh found his Instagram profile. It's posted in the Discord. Oh, if you want to join us on Discord, if you just head over to pfg.gg/links, you'll see a button in the upper right that says Discord. just hit it, and you will be given an invite to our Discord. You'll have to answer a couple of questions, but they're pretty easy. With that, I'm going to say thanks for being here. Thanks to Adam. Thanks for all of you guys for your questions. Get flat, stay flat, and we'll see you next week in the Flat Cave. Take care.